You ever notice how some things fit together perfectly, like they were made for each other? That's no accident, folks. That's GD&T at work.
Geometric dimensioning and tolerancing, or GD&T, is a system that engineers use to describe the exact shape and size of a part. Think of it like a blueprint, but with a whole lot more detail. We're talking about making sure that every hole aligns, every surface is smooth, and every part fits together the first time, every time.
Now you might be thinking, Mike, that sounds complicated. And you wouldn't be wrong. GD&T uses a special set of symbols that can look like hieroglyphics to the untrained eye. But don't worry, we're going to break it down together. Just like any good trade, it takes a little practice to get the hang of it. But trust me, once you understand the basics, you'll be speaking the language of precision in no time. Remember that Tower of Babel story? Yeah, nobody wants that on a job site. That's why we use symbols in GD&T. They're a universal language that everyone in manufacturing can understand, from the engineer who designs the part to the machinist who makes it. Each symbol represents a specific geometric control, like flatness, straightness, or roundness.
Think of it like this. You wouldn't build a house without a blueprint, right? Well, you shouldn't build a part without clear GD&T symbols either. They tell the machinist exactly what needs to be done to make sure the part functions properly. Without them, you're opening yourself up to a whole heap of trouble. Parts that don't fit, machines that break down, and a whole lot of wasted time and money.
Now, here's where things can get tricky. Just like with any good tool, you can have too much of a good thing. Overusing GD&T symbols is a common mistake that can lead to confusion and frustration. Imagine a blueprint with so many symbols and numbers that it looks like a Jackson Pollock painting. Not exactly helpful, right? When you use too many symbols, it can make the drawing difficult to read and understand. This can lead to mistakes during the manufacturing process, which can cost time and money to fix. Not to mention, it can create tension between the engineers and the machinists.
Working smarter, not harder. Practical tips for GD&T. So, how do you find the right balance? It's all about using GD&T strategically. Here are a few tips to keep in mind. Keep it simple. Use only the symbols that are absolutely necessary to define the part's function. Think like a machinist. Consider how the part will be manufactured and inspected when choosing your symbols. Communicate clearly. Use clear and concise language in your drawings to avoid any misunderstandings. Don't be afraid to ask for help. If you're not sure about something, don't hesitate to reach out to a more experienced engineer or GD&T expert. Remember, the goal of GD&T is to communicate clearly and effectively. By following these tips, you can use GD&T to create drawings that are both accurate and easy to understand.
A tale of two drawings, simplicity versus complexity. Let's look at a real-world example. Imagine you're designing a simple bracket. One engineer might create a drawing with a dozen different GD&T symbols, specifying every dimension and tolerance to the nth degree. Another engineer might use just a handful of symbols, focusing on the key features that are critical to the bracket's function. Which drawing do you think would be easier for the machinist to understand and manufacture? You guessed it, the simpler one. By using GD&T selectively, the second engineer saved time and money without sacrificing quality or accuracy.
The bottom line: clear communication is key. GD&T is a powerful tool that can help you create high-quality parts that meet your exact specifications. But just like any tool, it's important to use it wisely. By understanding the basics of GD&T and following the tips outlined above, you can avoid common pitfalls and create clear, concise, and easy-to-understand engineering drawings. Remember, folks, it's not about how many symbols you can cram onto a page. It's about communicating your design intent in a way that everyone can understand. Clear communication is the key to success in any trade, and engineering is no different.